All right, let's take a look here. So for part A, you've got a constant multiple here of 1 over 71, and I would highly recommend using that constant multiple rule and factoring it out front. Oops, that's a 2. Okay, and then from there, you should be able to use the rule right, where is it? Right here, this one, for the sum of all the squares. So you do want to have that one memorized. So basically n is your upper bound. So you take your upper bound, multiply it by your upper bound plus 1, multiply it by double your upper bound plus 1, and divide the result by 6. So from there, you would have the 1 over 71, and then you would replace the sum with your upper bound times your upper bound plus 1, multiplied by double your upper bound plus 1, all over 6. All right, hopefully this is making sense. Okay, and then from there, now the 71 maybe makes a little more sense. You could cancel things out. So the 71s cancel, the 6 and the 36 cancel, you're left with 6. And so all you'd have to do is multiply 35 times 6. Well, 30 times 6 is 180, and then 5 times 6 is another 30, and so you're left with 210. There we go. Hopefully that wasn't too bad. In my opinion, way better than doing it falling back on if in doubt, expand it out for 35 terms. All right, for part B, I feel kind of bad. I probably should have reminded you of a certain rule where in the past, back in chapter 8, we talked about how if you have the sum as I goes from 1 to, and in this case, I called your index in a different letter, but I hope it makes sense that that's okay. So if you have the sum as, as I goes from 1 to n of one function of I, oh goodness gracious, sorry guys, okay. One function of I, either plus or minus another function of I, then basically you can distribute sigma over either addition or subtraction. So you could have, so I'm writing two rules in one here where you've got the sum rule and the difference rule for sums. My high school math teacher used to like to say the sum rule version of this is the sum of the sums. No, wait. The sum of the sums is the sum of the sums. I don't know, something like that. I don't know. Apparently it wasn't very helpful to me. Okay. The point is, though, is that in this case, you could distribute sigma over subtraction. So you'd be left with the sum as n goes from 1 to 8 of n cubed minus, oh boy, I'm so sorry for what's happening here with my tablet. Minus the sum as n goes from 1 to 8 of n. Then from here, we have the green light to use those properties that we have memorized up above. So for this first one, this is just the sum of all the cubes for the first 8 terms. And so you would be using, can I find it? Yeah, you'd be using this formula right here, just where your upper bound is an 8. And so you would have 8 squared times 8 plus 1 squared, which would just be 9 squared. And then all over 4, like that. That would be the sum of all the cubes. And then you're going to take away the sum of all the n's. And so for this one, you would be using this property right here, and where you just make sure you put, your upper bound in for all the n's. So you'd have, you'd have your upper bound times your upper bound plus 1 all over 2, like that. Okay, now let's just simplify this down. So 8 squared is just 8 times 8, and 9 squared, I guess I'm just going to multiply that out and be 81. And The reason I didn't multiply 8 times 8 together, because I really want to just cancel things down and make it a little bit easier for myself. I'm also going to cancel this 2 with this 8. And so I just have to do, for this part, I have to do 4 times 9. Okay, so, oh goody. So I'm left with 8 times 2, which is 16, which is 16 times 81, take away 36. All right, 16 times 81, I think, is 1,296. And take away the 36, you're left with 1,260, I think. That is pretty much what you need to know. Make sure you have those formulas memorized. Otherwise, you will be miserable when you get to the test. Anyway, and you'll be miserable in chapter 11 too. So I don't know if that's enough doom and gloom to get you to memorize those formulas. But if you want to be a happy, healthy math student for the next couple tests, you should memorize those. Anyway, so let's move on. Section 8 for part 3 is going to go pretty quick. It's about finding quadratic models. And the goal for this part of the lesson is for you to be able to recognize when a quadratic model is appropriate, and then to be able to turn around and write a formula for the nth term. So for example 1, please consider how to write the nth term of each sequence as a function of n. Part A should be familiar to you from the past, and then part B will be less familiar to you. Part B is kind of where we're going with this lesson. So do what you can, and then check in with me in the next video, and I'll help you pick up the pieces.